Hey guys, hello. So yeah, it's Sunday. I thought maybe I'll have quality time to spend, but people they are crying. Can you fix this for me? Fix this for me. Uh, and we have some kind of urgent jobs. We only have 2 hours to fix this because the owner he said this weekend I want to watch soccer. This is some kind of 32-inch TV, Ecco model LH32. That's the model of this TV. The TV was booked in as no power. It's plugged in on AC adapter. No standby light, no sign of life. It's just dead. So what we can conclude by now, I think something is wrong on the switching power supply. So let me check out the board. We'll check together and try to find out what is the problem. This must be not more than maybe 10 to 15 minutes job. So let me check out the power supply. We'll come and we'll check together. Again, I took something like 5 to 7 minutes to take out the power supply. That's the motherboard for this cheap TV. So what can be faulty here? Let's check together. Diode mode. No. Volts, DC volts. We can't go on diode without checking the big capacitor. I don't want to be electrified, so we have to be sure that the big capacitor doesn't have any voltage and it's zero, no voltage, so we are safe. Now diode mode, checking for short, it's not shorted. The next thing, we have the switching MOSFET here on the high voltage area. You can see these double lines here, that the high voltage area, the primary stage, and here that the secondary side of the transformer. On the secondary, you can touch anything, but this side is high voltage. If you really don't know what you are doing, it's not a good place to like going random touching components. You get electrified. So there's no short here. The next step, checking the MOSFET, source source gate drain combination should not be mixed up. The MOSFET looks good. So why did this board die? Here we have a diode. Diode looks good. We do have the BIOS here. Pin number 4 ground. Pin number 8 good. Let's check the rectifier. We have like 4 diodes. Yeah, they are closed with some kind of glue. Like we need to get access to the pins so that we check if if this board died because of a fault rectifier. Checking those 4 diodes. Good, 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 good. Okay. You know what? Let's remove this black shoot. This one. I need to see the other side of the board. Maybe we can do something. Sunday, I should not take too much time. fixing something like this, we have to identify the fault quickly. The other side of the board looks okay. What I want to check, I'll check again those diodes on the other side just to make sure diodes looks good. What about the fuse? And the fuse is gone. The fuse is supposed to be like this. Check the fuse. It's not like 00. We have a blown up fuse. Now it becomes tricky. Do you think it's just the fuse? You see this black thing next to the AC connector? That's the fuse. The fuse is supposed is supposed to be like 00. Anyway, what I want to see is a big explosion. Let's come with our own fuse. Let's come with our own fuse. The fuse is just a wire, nothing special. Let's come with our own fuse and see if something is going to explode. Because I checked the rectifier, looks good. I checked the MOSFET, looks good. But I don't trust that here we only have a fuse, a blown up fuse. So are we ready to see the spark? Hopefully everyone is ready to see the spark. I'll distance myself and I'll plug the AC adapter. If we didn't see spark, it means that the board is fixed. No spark. Let's check some voltage on the big capacitor. There's no more spark. No spark at all. So we are lucky. No, we don't have voltage here. Okay. Why? AC in. Is this multimeter okay? Diode. AC in 0. Why? Why we don't have AC input 220? Do you have a broken cable? Now looks weird. Let's unplug here. Let's check our cable. We have like 25 volt, 21 volts AC. Let's put on diode mode. Let's check this cable. The blue wire is okay. Live wire along the way is broken. So now you understand why the fuse is was blown up. We have a fault cable here. I suspect here I suspect something here. So this fuse blown up because maybe there was a touch here. Because I don't think the cable was broken, but we'll check. We'll check from here to here. Live, good, neutral, good. So this is good. The other side, live to live here, good, neutral, good. So now you understand why the fuse blown up. Now you know why the fuse blown up. Maybe there was a touch here. Well, what I want to see is to see this TV working. That's all what I want to see. Insulation tape. So if there's a secondary fault at this moment, we must see some sparks. If we didn't see the spark, that means we are done. That means we are done. Okay. So checking again. Our cable, live, good, neutral, good. So now we must have voltage on this board. Either we are going to see spark or the board is fixed. You see this spark? That's bad. You see this spark? Now the fuse blown up after something else was shorted on the board. That's bad. That's bad. Volts on the voltage diode. So the MOSFET was shorted, but I checked it before, there was no short. Now it's now shorted. Short. So we need to take down the MOSFET. Let's take down the MOSFET. I was thinking this is going to be a very short video. You know, I love electronics when I'm seeing some spark, trying to fix something, and you have spark. Let's take down that MOSFET quickly. You know the switching MOSFET, which is on the high voltage area. Yeah, the board is still sucking some heat. That's the MOSFET. Next to the MOSFET, we have also a blown up resistor, which I don't know the value of this resistor. Now the resistor is gone. We took the resistor and the MOSFET. Now I want to check for short again. We still have a short. And probably what is shorted, the rectifier bridge is also gone. The rectifier seems to be gone also. Yeah. Yeah, this board want to challenge me. So we still have a short. What I want to do, let's cut those diodes. You know those 4 diodes. Was we need to check them one by one. Probably they are not all shorted. This one is gone. This one is gone. 3 diodes are gone. So 3 diodes are gone. The switching MOSFET is gone. That's interesting. It's Sunday. I don't have time to desolder the diodes from the board. I'm sorry. I'll do some shortcuts here. I'm really sorry for the shortcuts because it's too long to desolder the diodes. I'll just cut the diodes and that should be okay. We need like 3 diodes to replace those ones. Let me check these diodes before. Good. Good. And good. So this board basically just died. But you know, you have seen when I checked at first, everything looks okay. But I was just doubting if it's only the fuse. Because 99% when you see a blown up fuse, something else is gone. Something else is gone. In most of the cases, because the fuse is there to protect the circuit, so the fuse is blowing up after something is getting shorted. In most cases. The last diode. All the diodes in place. So now checking for short on the capacitor after we have replaced those diodes. On the capacitor it's not shorted. All our diodes, they are now okay. Now we need to replace that resistor, which I don't know the value of this resistor. That is another problem. but I'll try to look for board for space and took a resistor that is doing same job. Resistor that is doing almost the same job. So many boards for space. So many boards for space. So whatever the fault here, 100% sure we will fix it. We are now replacing the resistor, and after that we will replace the MOSFET. Now the MOSFET. We have replaced the resistor, we have replaced the MOSFET. But I need to check few things. Good. I think we are ready to test for the second time. What do you think? Let's wait for the board to cool down and then we can test together. Our board is now cool. So let's plug the AC adapter. Got the AC adapter plugged. Let's try to check some voltages. DC. I'll check on the big capacitor. 316. That means our rectifier is now working. You can see on the screen 316. Okay. Okay. But this board still looks weird because we have this thing. Looks like a thermistor or something on the input is cracked up. So before we can test, I want to replace that thing quickly. Why? Looks like it's a varistor. I'll replace it quickly. Now you see, just to fall in. So let me replace that varistor quickly. Hey, this board still have some power. Really? 310. That's a bad sign. I'll tell you why. I will tell you why this is a bad sign. If the capacitor is still charged after 3-5 minutes after you have taken it to power, probably the main chip, the controller, is gone. But we'll see. We'll see about it. Let's assume everything is fine. Let's just assume that everything is fine here. That's fine. It's easy. I'll look for the cable. You see this cable with the standby light. With this cable, we can see if we have done something or we are still yet to start. No? We changed the rectifier, we changed the MOSFET, still we don't have light. The fuse, we come with our own fuse. The fuse is good. What is left on the high side, which is causing this MOSFET not to switch so that we get voltage on the secondary. You know what is the problem? There's no need to check. Is this small guy here? Maybe you can see, you see this 6-leg small guy? That's the main chip. It's gone. Because it's next to the diodes which I took out, so there's no way that chip will remain alive. No way. Probably the thing is I don't have this chip. I don't have one. Let's try. Let's check just a random chip from any chip board and see if it's working. But I know where we are going from this moment. I know. It's just a trying, but for sure, maybe I can see what kind of chip is this. J31. Let's check this one. I took a different chip from a different motherboard doing same job. Let's wait for the board to cool down. Then we can check this chip. Chip number is different, so either we win or lose. The only trust that we have is that the chip is doing some job, but it's different numbers. Let's test. No, it's not working. It's not working. Let's discharge the capacitor. So now what we should do now, you know what? It's that moment to do the dodgy thing. So what I will do, I will look for another power supply who will destroy the whole primary stage, and we will try to look for another board and come with the primary stage here. Because the problem is this chip is not communicating with the MOSFET to switch the transformer. So our voltage is ending on this capacitor, this big capacitor. Here on the secondary we have 0. We don't have any voltage, but I'm sure if I'm to check on the secondary side, we don't have any short. But you can confirm that checking on the last pin of the BIOS is good. On these coils, or they are not shorted. So the problem is not from the secondary. The problem is our driver is gone and we don't have any, but we need this TV working. Okay, so let's do it. Let's do it. No matter how long this video gonna take, but we have to do this. Now let's desolder the primary stage of this transformer. Ferrite transformer, that's the name, is stepping down voltage. What's on the secondary? Basically we don't need too much voltage there. The voltages are lower. What is connecting the high side and the low side? We have the optocoupler. We need to desolder one side of the optocoupler also. Optocoupler. That's good. We have this capacitor. This blue ceramic capacitor. Okay. So we can do it. So I need to cut this area. So I'll cut this area. After cutting the area, we'll try to do together, okay? So we are only left with the one option here. So what I've done so far, I took out disconnected the transformer, I disconnected this small capacitor and the optocoupler, and that's all. So we need to destroy the primary stage because it's not working. We don't want it anymore. We don't want this anymore. We tried to fix it. The faults, there are too many. So we've done what we did. Until at a point when you can't do anything. What else? All what we need is to be careful that we won't break the secondary side. We don't want to break the secondary side. We don't want to destroy the secondary side. We only want the secondary. We only want the secondary. So, how are you doing, guys? Looks we are good. We are good. All these pieces from the secondary, we don't want them anymore. So now let me look for a donor board and we'll try to find a board with a good primary stage. So what did I found? I found this board. I don't know for which TV. So on this board, all what we need is to cut and take out the primary stage of this board. That's all what is needed. Let's work on the secondary board. The first thing, let's disconnect the transformer. Let's disconnect the transformer. This method can be helpful to someone who is living in a developing country like Zimbabwe, which I'm living, where it's hard to get the chips. But you want the job done as soon as yesterday. So you have to find a way to solve the problem. You have to find a way to solve the problem. There must be a way to solve this. So now our area of concern is the primary stage. I need to check few things. If these transformers they are common, okay. Yeah. Looks as if we are fine. Two pins together on the input. Okay. Now, this is a donor board, so we can destroy this transformer. We don't need this transformer here. So let's do it again. Same like what we did. Let's do it, guys. It's now that moment to destroy the power supply. Let's destroy this power supply. Or what you need to make sure is that the secondary side you are safe. You don't want any crack there. Otherwise, it will be a waste of time. Otherwise, it will be a waste of time. It's not easy to cut the PCB into two pieces. It's not an easy thing. It's not an easy thing at all. It's not an easy thing, but we have to do it. We have to do it. We have to do it. I didn't thought that I would spend an hour fixing such kind of rubbish TV. But I can see it's now close to an hour. I can see on the OBS now close to an hour. Okay. Here supposed to be the opto thing. And where's that blue capacitor here? Okay. Let's do it. Let's do it. If you are in TV repairs, someday you come across with something like this. And you will know the way to go. You will know the way to go. No such kind of scenarios when you just want to get the job done, but zero space. So we have this part for the secondary. Checking things after spending time is sound a state of confusion. I was supposed to do that at first. So now we need to join. Now we need to join this here. So I'll start to join the transformer. Yeah, I know. Let's first join the transformer. Join the transformer. I'm trying to align the pins of the transformer properly before I solder them, or I can use some wires. Let me use some wires so that everyone will see what we are doing here. Now we need to join this. This is the secondary of the original board. This is the primary, which I took it somewhere from boards for space. Now we need to join the two. We need to join the two. Hopefully it will work. Hopefully it will work. Was from experience, I know if the MOSFET is good, the rectifier is good, the fuse is good. We checked everything on the primary, still nothing is working. The problem will be the driver. 99% the problem will be the driver. Because I checked everything, I checked the diode, I checked all the components. Still is not working. What we can do? What we can do? Maybe we have a better method. to bypass the driver. If you have any method, let me know. Let me know, because I'm also learning. All those 4 wires for the transformer. And we have one for the capacitor, and the 2 wires for the optocoupler. All what we need is a working board. After that, we'll play with hot glue to stick everything in position. After satisfied that the board is working, sometimes it's easy, sometimes it's hard. Sometimes it's short, sometimes it's long. Sometimes it's just a waste of time. If you are doing electronics, expect anything. Expect anything. So now we'll start with connecting the our opto thing. Our opto thing, the wires to the opto. The wires for the capacitor. The TV must work fine. The TV has to work fine. It has to work fine. First pin. Let me cut these wires. They are longer. We are dealing with high voltage here. That's why I've used these big wires to carry more power. because we are dealing with high voltage here. We don't want to do something that we will regret. We are about to finish. Do you think this is going to work? Do you think this is going to work? Do you think this is going to work? So what we have done, we've connected the transformer, ferrite transformer. We connected our our non-electrolyte capacitor in the opto coupler, which is being switched by TL TL TL431. This one, maybe you can see it between these two capacitors. We have a small chip there. TL431 shunt regulator. So let me look for the AC cable and then we test. Now we need to connect our AC cable. I'm curious, what more do we need? We need this panel with the standby light. That's the only way to see if we now have voltage on the secondary. Let's plug in. Check here. It's working. We have standby light. Let's try to power on this board. On. And it's changing to green. Let's check some voltage on the output. Let's check some voltage on the output. On the last pin of the BIOS, 3.32. What about on this coil? 1.3 on this coil. 5 volts on the backlight, 19 volts. So it seems as if it's working. Off, red, on, green, off. It's now off, it's now on. So for sure, we now have a working TV. So let's disconnect here. What more we can do here? We need to insulate those wires with hot glue. So that's how you treat the situation. I'm insulating those wires with hot glue. Fine. So what I will do, let me put all together and we'll come back for the final test. Okay? So I just put everything together and now it's time to test. Now it's time to test. Yeah, the video was very long and I want to apologize for that. That's our TV, Ecco. Here, yeah, it's already plugged in power source. You can see this standby light is red, power on. You can see the echo sign. And our TV is working fine. So basically, as that's how you can modify a switching power supply. Yeah, hopefully this video is very important and someone is going to learn something, because one of my subscribers requested for such kind of video, and today we are lucky we have a TV which wanted to some switching power supply modification. You cut the primary stage, you modify with another primary stage. Why did we do this? That is a very good question. We did this because you check everything on the primary stage, the the rectifier is good, the switching MOSFET is good, the fuse is good, all the diodes, everything on the primary is good, the transformer is good, is not shorted. Probably that's the way to go. Our TV is working fine. You can see it's on. Even all the buttons, volume up, volume down, everything is working fine here. Everything is working fine. So I'll stop this video now. I can see on my OBS it's above 1 hour trying to modify and fix things. So like, subscribe. Don't forget to turn on the notification bell for future updates. See you on the next one. Bye.